Good morning, everyone. Myself, Sudha Rani. Today, I am going to explain about the topic classification and classifiers in information retrieval system. Classification is a fundamental task of machine learning and data mining, where the goal is to assign predefined categories or labels to input data based on their features. So classification, we used to define like the data used to be categorized or the data used to be divided into two parts. Maximum here, the types of classifications we use are maximum binary classification, where it involves categorization of data into two classes, like classification done for positive, negative, or pass or fail, high or low, good or bad, and so on. So classification, types of classification, mainly we used to take binary classification, and we also have the multiple classifications also. So types of classifications are both binary classifications, where we divide only two parts, two classes, and multiple class classification are also there, where it involves categorization data into more than two classes, such as emails into different topics, classify images into different objects, and so on. Here, probabilistic classifiers, if you see the probabilistic classifiers, we use classifiers for the classifications. To apply the classification on any data sets, we use the classifiers. Here, let us check some of the classifiers which are using for the classification. The first one is probabilistic classifier. Probabilistic classifiers are classification algorithms that not only predict the class label of input data, but also provide a probability or likelihood estimation for each class label. Like if you get the feedback, for example, if you take any example of online stores reviews or the feedback, we used to consider positive review and the negative review. And generally, if you tell the feedback is the positive or the negative, it can be considered as the binary classification. But if you want to give the exact results of the feedback, like reviews like 4 out of 5, 3.8 out of 5, so that kind of things, exact values, that kind of things will come under the probabilistic classifiers, where it is going to give some label part. For example, results, pass or fail. So if the student is passed with a percentage of 89, so such kind of things are considered as a probabilistic classifiers, where it will give the estimation or the label for the class. Here we can see the Bayesian classifications, Navi-Bayes classifications. So comes to the Bayesian classifications. Bayesian classifiers are a common type of probabilistic classifiers based on Bayes' theorem. So for the probabilistic classifiers, we use the Bayesian classifications, which is the most common probabilistic classifiers we used based on the Bayes' theorem. So this calculates the probability of each class given the input features and select the class with the highest probability. So Bayesian classification, they can generate it will take the input features and select the class with the highest probability. Navi-Bayes is a popular probabilistic classifier that assumes independence between features given the class label. Despite its simplicity, it often performs well in practice and is particularly efficient for text classification tasks. So Navi-Bayes is popular probabilistic classifiers, where it is going to perform the text classification task. And for the information retrieval system, Navi-Bayes is going to use much as we are using the data sets for the text classification. Another one, probabilistic output. Instead of providing a hard class label, probabilistic classifiers output a probability distribution overall possible class labels. This can be useful for decision-making process that requires uncertainty estimation or for cases where assigning a single class label may not be appropriate. After the probabilistic classifiers, let's see the linear classifiers. As the name indicates, linear classifiers are a class of classification algorithm that makes predictions by combining linear combination of the input features. The classifiers assumes that the relationship between the features and the class label is linear, meaning that the decision boundary separating different classes in a linear function. So here we are having the linear decision boundary, linear models. So linear decision boundary, linear classifiers defines a decision boundary that separate different classes in the feature space. This decision boundary is typically a hyperplane in higher dimension feature spaces, just like the boundaries 0 to 10, 11 to 20, 21 to 30, like that, where we used to have the lower boundary as well as the higher boundary. By considering the lower boundary and the higher boundary, we will take the linear decision of the boundaries. There is a clear line between the boundaries. If the boundary is above, then it will shift to another group. So in general, a boundary is a line. We are having the 2-dimension or a plane or in 3 dimensions. Linear model. Linear classifiers are based on linear models that learn the coefficient associated with each features and combine them linearly to make predictions. Here for the decision classifiers, we can represent the formula f of x equal to w to the power of t into x plus b, where x is the input feature vector, w is the weight vector, b is the bias term, wt denotes the transpose of the weight vector. The decision boundary is a set of points where f of x equal to 0. This is a formula for linear classifier. Logistic regression, support vector, perception, linear discriminant analysis. So logistic regression, despite its name, logistic regression is a linear classifier commonly used for binary classification tasks. It models the probability of the positive class using a logistic function. So where logistic regression, it supports a binary classification where it is having the positive class using the logistic functions. And next one is the SVM, support vector mechanics. So SVM is a versatile linear classifier that finds the optimal hyperplane that separate classes with the maximum margin. Perception algorithm is a simpler linear classifier that iteratively updates the weight to minimize classification errors. So to minimize the classification errors, we use this method or the algorithm. Linear discriminant analysis, LDA. LDA is a linear classifier that models the distribution of each class as a multivariate Gaussian and finds the linear discriminants that maximize class separation. Principles of operation. Similarity-based classifiers make predictions based on the similarity measures between the features of new instance and those of instance in the training datasets. The assumption is that instances with similar feature vectors should belong to the same class. So here we are having the nearest neighbor algorithm. The most common type of similarity-based classifier is k-nearest neighbor, that is called as KNN algorithm. In KNN, the class label of a new instance is determined by the majority vote or the average of the k nearest in the feature space. The choice of the distance metric plays a crucial role in determining similarity. Key concept: Key concepts of the K-means algorithm. The parameter in KNN algorithm specifies the number of nearest neighbors to consider when making predictions. Distance matrix K is the parameter in K. The parameter K in K-means algorithm specify the number of nearest neighbors to consider when making predictions. Distance matrix. The choice of distance metric affect the notion of similarity between instances. Different instance metrics may be more appropriate for different types of data and feature spaces. Weighing some variations of KNN assigns weights to the neighbors based on their distance to their query instance. Closer neighbors may have more influences on the prediction. Advantages and limitations. Advantages of KNN algorithm. It is simplicity and flexibility are the primary advantages of similarity-based classifiers. They can handle complex decision boundaries and or robust noise in the data. Limitations, they can be computationally expensive, especially with large data sets, as they require sorting and searching the entire training data sets for each prediction. Additionally, they may perform poorly in high-dimensional feature spaces or with imbalanced data sets. Multi-category ranking and classification. Multi-category ranking and classifications involve assigning multiple categories and ranking them based on their relevance or confidence scores. Multi-category classifications, also known as multi-class classifications. So just now we've seen that classifications, we are having both binary classification as well as a multi-class classification. So the multi-class classifications involves categorizing input data into more than 2 classes or categories. Various machine learning algorithms can be used for multi-category classification, especially decision trees, support vector machines, which is called as a SVM, logistic regression, neural network, and ensemble methods like random forest or radiant acoustic. Evaluation, here the performance metrics for multi-category classification include accuracy, precision, recall, F1 score, confusion matrix, and multi-class ROC curves. So this is the explanation regarding the classification and the classifiers. Now let us check another topic. I want to explain baseline algorithms. Baseline algorithm provides a starting point for its task, enabling researchers and practitioners to evaluate the improvement brought by more advanced models. Although not optimized for accuracy, baseline algorithms are very used to implement and offer a quick understanding of data structures and inheritance challenges. Baseline algorithms in sentiment analysis is a simple method used to predict sentiment categories. Example, positive, negative, or neutral. For example, take a live example regarding the sentiment analysis. Nowadays, everything is online shopping. So if you want, as a customer, if you want to do any online shopping, first we used to check for the reviews, points, or the feedback. Whatever the feedback the customer is giving, it is taken as a text. Just like, oh, the product is very nice. I recommended the product, or it is not worthy of the money. Very bad product. Cloth is very transparent. Like that, the customers used to give text-based feedback for that product in online. So when we consider the feedback, everything can be considered as the text. So from the text-based, we used to consider, or we have to generate which one is a positive feedback, which one is the negative feedback. So for that, here we are doing the text pre-processing techniques, like we are identifying the keywords, just like this. Here we are identifying the keywords, like reviews is like I love this product. Here identifying the keywords, like love, positive keywords and the negative keywords. Here the positive feedback, positive keyword is just like love. So the system can generate this as the positive, excellent, again positive, very satisfied, again positive, terrible experience, not happy. Here the keywords are terrible, not. So the system generate negative, worst product. Here the keyword is as worst and the feedback is negative. So here the count, let's see the count of classes, positive 1, 2, 3. So the positive is 3 and the negative is 1, 2. The negative is, the count of negative is 2. So obviously the count for the positive is high, that is a 3 out of 5. So we used to take the feedback as the system sentiment analysis algorithm will generate the feedback as a positive, as the count of the positive is 3. This is something related to the sentiment analysis. Now again come back to baseline algorithms. So baseline algorithms in sentiment analysis is a simple method used to predict sentiment categories, either it is the positive, negative. So in the sentiment analysis, we use the baseline algorithms which to categorize the positive and the negative classification. In that, here we are having baseline algorithms, majority class baseline, random classifiers, lexicon-based approach, Naive Bayes classifier, evaluation metrics. Majority class baseline. The majority class baseline is the simplest possible prediction method used in classification task. Includes sentiment analysis. It predicts the most frequent class found in the training data sets, regardless of the input. So baseline majority class baseline, it does a prediction in the classification task. So it used to predict the most frequent class found in the training. Then how does it work? So it works by count the number of samples in each sentiment classes, identify the most frequent class, predict the class for all inputs. Here, whatever the example we take, exactly it suits for this majority class baseline algorithm. So what first it is doing? First it is taking the feedback, and then it is counting, and it is checking which count will get much, either the positive count or the negative count. Whatever the count it is getting much, it is considering that category as positive or negative. Next one, random classifier. Random classifier in the context of sentiment analysis refers to using a random forest algorithm and ensemble learning method to classify text sentiments as positive, negative, or neutral, providing insights into public opinion or user sentiment. So how the random classifiers, so it does in context of sentiment analysis refers to using random forest by the reference of the random forest algorithm. It used to do the classification on text sentiments as again positive, negative, or neutral. So what is a random forest classifiers? It is an ensemble method, and random forest is an ensemble learning method that combines multiple decision trees to make predictions. So it used to do bagging. It used a technique called bagging, bootstrap aggregating, where the multiple subsets of training data are used to train individual decision trees. Random subspace, each decision tree is trained on a random subset of the features in the data sets. Prediction, the final prediction is determined by averaging the prediction of all the individual decision trees. Next one, lexicon-based approach. Lexicon-based approach. Lexicon-based approach is a widely used method in the sentiment analysis that relies on a predefined list of words to determine the sentiment orientation of a piece of text. So sentiment lexicon-based approach is also a sentiment analysis, but it's different from the previous algorithm. It used to rely on predefined list of words. For example, if you take the example of when you are searching for a word in search engines, for example, if I am giving like machine, then automatically machine learning the word used to get, or immediately artificial intelligence I used to get, so on. Means it used to rely on the predefined list of words. What the predefined list of words your data sets are having, that predefined words used to be generated when you are searching something in your search engines. This method does not require training data, making it suitable for scenarios with limited labeled data. Sentiment lexicon, a collection of words and their associated sentiment polarity. Words can be labeled as positive, negative, or neutral. Example, sentiment wordnet AFINN NRC emotions lexicon. Polarity score. Each word is assigned a polarity score. Example, +1 for positive, -1 for negative. Like just now we taken this example. See here, I said that love is a positive word. So if I think love can be as a positive word, then I can assign +1 for this word. So positive can be assigned with +1. Terrible is a negative word. If you think terrible has to be assigned as the negative word, -1 can be assigned for the negative as it indicates the -1 can be assigned for the terrible as it indicates the negative word. So that is polarity score, where every positive word is having the +1 and negative word is having the -1. Next one, text pre-processing. Tokenization, we can apply the tokenization, where the tokenization is again splitting text into individual words or the tokens. That the tokenization is dividing every sentence into the separate words. We can consider them each word, keyword, or the tokens. Second step is stop word removal, eliminating common non-informative words, just like are you coming today? Are you coming today? If you take this example, or are you coming today? Then it is just non-informative word. Is, that, are, them, where, like that. This kind of word we used to delete such kind of common or the non-informative words and generated only keywords. That concept is called as stop word removal. Next, lemmatization and the stemming. This both lemmatization and the stemming, they are used to reduce words to their base or root form. For example, coming. Coming is the word where come is the base word for the coming. Root word for the coming. The actual word is the coming, but the root word or the base word is come. So whatever the coming, came, come. So all kind of words, this all kind of running, run. So such kind of things all are having the one base or the root word. Bringing that words to the base words are called as the lemmatization or the stemming process. Types of lexicon-based approaches: dictionary-based approach, corpus-based approach. Here we are having two types of lexicon-based approaches: dictionary-based approaches and the corpus-based approaches. If you see dictionary-based approaches, where use manually or semi-automatically created lexicons using WordNet to expand synonyms and antonyms relationship, where the words are generated with the alphabetical order. where the words are starting with the A or the words starting with the E, all are to be at the same place. So such kind of things, the traditional one, such kind of things are called as a dictionary-based approaches. Disadvantages is high interpretability. Limitations cannot handle domain-specific language well. This is a traditional one, dictionary-based approach. And next one, the latest one which we are using is a corpus-based approach. Just now I said you one example that if I given as M in my search engine, then it used to get as machine learning. If I give as A, then it used to get as artificial intelligence. Either that M, L, they both are not means dictionary based. They both are not the nearest to words. But how they are generating? They are because they are the most common possible combination of words. So such kind of possible combinations of words are called as what? Corpus-based approach. For example, if amazing frequently appears with excellent, if I given as artificial, immediately it used to intelligence used to reflect. So such kind of most probable, most are you doing? If I type as are you doing, then immediately I used to get as well in continuation. So such kind of most possible frequently combined words are called as a corpus-based approach. Here the advantages for corpus-based approaches can adapt to new domains or slangs. By using this, we can adapt any new kind of slangs. Limitations requires large corpora and complex processing. Obviously, it requires large corpora because we have to match up with all the possibilities. We have to generate with all the matchings, all the possibilities of the combinations of the words. Next, Navi-Bayes. Navi-Bayes is a probabilistic machine learning algorithm based on Bayes' theorem with a strong assumption of future independence. In sentiment analysis, it's used to classify text into sentiment categories like positive, negative, or neutral. So here, Bayes' theorem, it shows this formula where PC by X equal to Px by C dot PC by Px. PC by X is the posterior probability of class C given input X. Px by C is opposite. It gives likelihood of input X given class C. P of C, clear probability of class C. P of X, evidence probability of input X. So this is the Bayes theorem, and Navi-Bayes is depends on the Bayes theorem, and it is a probabilistic machine learning algorithm based on Bayes theorem. The last one is the evaluation metrics. Evaluation metrics are essential to measure the performance of sentiment analysis models. This metrics helps us understand how well a model can classify sentiment like positive, negative, or neutral from text data. Not only positive, negative. Evaluation metrics, if you take the simple example of our result analysis, the first results can be categorized as a binary classification like pass or fail. Here, the results, it is having only binary classification, pass or fail. And if take another example, like if the student is passed, then again the classification is multi-class classification, where it is going to have the parameters evaluation metrics like A grade, B grade, C grade, D grade, and so on. But for the evaluation metrics, for the evaluation metrics, we have to consider the lower boundary as well as the higher boundary for the metrics. Like A grade, we can consider A grade as above 75 to 80%, B grade from 65 to 75, C grade 55 to 65, so on. So whatever the metrics we are assigning, the values we are assigning for the performance, it is considered as the evaluation metrics. So totally today we've seen what is the sentiment analysis. And here, let's check one more point regarding the sentiment analysis, how it works. I explained you the definition of sentiment analysis and where we are using the sentiment analysis, and this is the most important one in the neural network processing NLP, sentiment analysis. And where the sentiment analysis, how it is going to work means, first data collection, feature extraction, model training, and sentiment prediction. So sentiment analysis, it used to work by taking the data collection. Data collection means sentiment analysis begins with collecting and cleaning text data from various sources like social media, customer reviews, emails, and surveys. So from all these sources, it is going to collect the data and it is to clean the data. And again, the cleaning of the text again comes like text pre-processing, removal of stop words, lemmatization, stemming, all these things, tokenizations, all these methods comes under again cleaning of text. The procedure text pre-processing will call as text cleaning of text in NLP. So it will perform the cleaning of text, takes the data from sources from social media, customers' reviews, emails, and surveys. Next one is a feature extraction. After the data collection, NLP techniques are used to extract relevant features from the text, such as keywords, phrases, and sentiment-related works. Next, model train. Machine learning models are trained on labeled datasets to learn how classify text sentiment prediction. The trained model is then used to predict the sentiment of new and unlabeled data. So here it is the small explanation regarding the sentiment analysis and the baseline algorithms. Hope you all understand. Thank you.